Good morning, students. Here I am having Mollier chart or Mollier diagram in SI unit. This chart is very important in finding the enthalpy values. So this is purely HS diagram. See here, this is specific entropy versus specific enthalpy versus specific entropy, right? So here he has mentioned wrong. It is again specific enthalpy. It is he has mentioned wrong here, and it is specific entropy, right? So this diagram, you feel it is very large and it has so many curves. It is very difficult to find out. These mindset, please you remove from your mind. So it is very easy than finding whatever you used to find from the steam tables. No, that values directly you get here without any calculation. So you are finding S1 is equal to S2, then you are finding X, then you are finding H2 value, then using formula H2 is equal to HF2 plus X HFG2, you using that formula to calculate H2. But here no need, directly you will get these values are H values and these values are S values, and here you just see the curves. So this curve, whatever curve in this fashion it is going, no dark lines like this, these are all dryness fraction lines. So this dark line is saturation line, and here the dryness fraction will be 1. So here dryness fraction is 0.95. Here dryness fraction is 0.9, 0.85, 0.8. So this any value if you want to plot here, you have the dryness fraction values. Important are three values. One is dryness fraction, constant temperature, and constant pressure. Constant volume, specific volume sometimes we use. Other than that, there are no anything other than that. There are four lines here. One is what? Dryness fraction values, constant pressure values, temperature, and specific volume. So specific volume is used to find out the pump work. So from here only you can find VF2, or else you can go for the steam tables. So to plot a single point, you need two values. Either they have to give you temperature and pressure, or you have to have dryness fraction and pressure. So first point, how you will draw? If I give 150 bar, where you will draw? 150 bar pressure. 150 bar pressure is here. So whole this line is 150 bar. Where you will plot? Suppose he has given a steam enters at 150 bar and 600 degree Celsius. So you see this. So this is 150 bar, and wherever there is 600 degree. So here it is 600 degree. Here it is 150 bar pressure line. It is going like this. So here these two will meet, and here you can put a dot with your pencil. Corresponding to this point, if you just drag this horizontal line, you will get H value to this point. Or if it is inlet to the turbine, then you will get directly H1 value from this. Suppose what I am saying, some 100 bar pressure and 550 degree. 100 bar pressure is here. So drag this up to 550. So 550 temperature is here. 100 bar is here. So these two will meet here. From this point you can just take this 3500 value. 3500 kilojoules per kg. It is H1. So there is no need of calculating HF, HFG and other things. So these problems are also used in the steam nozzles, and but now I am solving one problem on reheat cycle. If I solve one problem, it is going to cover two numerical from the VTU question paper, which are very much similar. What is difference between those two, I will explain in this one while solving the problem. First, I have sent you the PDF, that you just look into that. Don't leave the problem. It will be asked for 10 marks, 12 marks even sometimes. Only HS diagram contains what all values? Dryness fraction value, constant pressure lines, constant temperature lines, and specific value lines. So these are the this one. According to that pressure and that temperature you need to plot. Then for second value, what he will be giving, either he will be giving pressure or dryness fraction. Up to that you should drag that line, you will get the second point. Take that horizontal of that, you will get the H2. Similarly, H3 and H4 you can get from the steam tables and or Mollier chart if possible. So usually we are using this Mollier chart in the reheat cycle calculations and steam nozzles. Steam nozzles problems are very easy. You should not leave steam nozzle problems. Thank you.